Hello there. In this video session, we are trying to learn how to find out the centroid for the line segments. As we know, the centroid is nothing but the total length or the mass is going to be concentrated at one point. We are assuming that it is passing to that point so that we will get the balance. So in these connections, today's topic is going to be, we are taking the line segment. So in this case, the line segment we are going to be considering as a one-dimensional body. When we are going to be say the one-dimensional body, it means that throughout the length, the cross section is going to be the same. Then we can say that this is going to be a line body. So suppose you can take a beam, then what will happen? Throughout this length is going to be cross section is the same. Suppose I have taken a marker here. Can you see the cross section of this one? It is in the circular in shape. But when I am going to be making the number of parts, there we can see throughout this length of this pen, the cross section is going to be the constant. So then we can say those will comes to the one-dimensional bodies, and now I am going to be taking the line segment. So before do this one, I am going to do some assumption. What I am going to be assuming? So assume the first one is going to be the body is in the curved shape. So the first one is going to be it is in the curved shape. The second one is going to be there, that is the homogeneous. So the second one is the homogeneous. It means that from this point to this point, the system is going to be have the homogeneous. It means that throughout length, the distribution of the atoms are going to be in a proper way. So the systematically it is distributed. At the same time, the density also we are going to be making the constant. So our rho is nothing but here is the density of this material. That is going to be C is going to be the constant. And similarly, we do have the third point I am going to be considering here. So that's going to be the third point, the uniform cross section. Uniform cross section I am going to be considering. What is the uniform cross section here? That's going to be, you can assume it, the area is going to be the S square or any one regular shape. It is going to be maintaining from this point to this point. That's I am going to say A is nothing but the area of this cross section that is equal to constant. So these the 3 points we do have considered, and the fourth one is going to be length is going to be I am going to be considering the length is equal to L I am going to be considering. Thus I can take it this way. So this is going to be your length of the line segment. So then what you want to do in this one, we need to find out the centroid with respect to the certain reference points. In this case, I am going to be taking the two coordinates in the x direction as well as in the y direction, so that I can try to calculate that part. So now I am going to be taking the coordinates. One is going to be the y axis, second one is the x axis. This I am going to be say the x, and this is I am going to say the y. So then in this case, x and y we have taken, we need to find out the centroid with respect to this y axis as well as the x axis, so that we can find out the centroid with reference to this. So then how would you do this part? So as we know that, so this is going to be the total length of the line segment we do have. So then what I am going to do, I am going to be taking the total length is going to be available as the L we do have. At the same time, if you want to find out the centroid for this kind of the objects, we need to make it the number of divisions. That means I am going to be making the infinitesimal the lengths of this given the segment. That means I am doing the partitions. So in this case, I am going to take here. Can you see? This way we need to take the number of elements in this case. Each element has x going to be 1, 2, 3, 4. Like that we do have. So the number of elements we do have taken, at the same time each element is going to be making at a length of del L1. So del L1 is going to be the length of the first element. The del L2 is going to be the length of the second elements. In this case, the first step we did it, the number of segments we made it. At the same time, we have measured the each elemental length is going to be del L1. So that's going to be elemental length is going to be del L1, del L2, del L3, like this. So that means the length of the each elemental the element is going to be this much. At the same time, they are going to be located from the reference axis, the x as well as the y. Suppose this is going to be the first segment. So for this part is going to be, we can see from the y reference, what is the distance this one? That's the distance we measure on the x axis that I am going to be saying. This is the x1. Then what is the reference from the x-axis y distance? that's going to be the y1. Can you see? This is going to be the y1 distance we do have. Similarly, for the second part is going to be, this is going to be x2, this is the y1. So then in this case I'm going to be writing the with reference to y axis. What is the distance of this element 1? So element 1 distance is going to be, what is the distance from the reference 1? That is going to be the x1. And similarly, second element we do have x2. So this way, x3, x4, x5 distance are going to be the number of elements we have taken that we are measuring with reference to the y-axis. Similarly, the elemental distance with respect to x-axis. So with respect to x-axis, what will happen? This is going to be the element 1 is equal to, what is the distance from this point elemental 1 from the x-axis? That's going to be the y1 distance it is existed. That is the y1. Suppose the second element is going to be the y2, and similarly the third element is going to be y3. So can you see, this way we are going to be identifying the references. That means from the references x1, x2, x3, like that we are going to be calculating. Now we can see that each element we have seen that. And now we are going to be saying the total mass of the system is going to be m. I am going to be saying this is going to be your total mass of the system, that m is equal to, what is the formula? That's we do have the density into the volume we are going to be saying. So then how would you write the volume here? The rho, that's the volume, is equal to area into length. Area into length I am going to be taking. This is the total mass of the length of the line segment. But when it comes to the single element, suppose you are going to be taking the element 1. So can you tell me what is the mass of this one? So that I am going to be writing del L mi. So in this case, del mi I am going to be taking, that is the mass for the single element mi is equal to, we do have the formula, rho into this part you are going to take. Already we told the rho is going to be, the density is going to be constant because it is a homogeneous, and A is going to be the uniform cross section, and then L is going to be varying. For this element is going to be del 1. So that I am going to be taking, this is going to be m1 is equal to rho A del L1 I am going to be taking. So can you see how we modified from the total mass to the single element? Similarly, the element 2 if I am going to be taking, suppose element 2, what is the del m2 is equal to, what is the formula we do have? That's going to be rho A del L2. Similarly, for the element 3, 4, 5 also we are going to be doing in this way. In this case, the density and the area is going to be the constant, and only the length is going to be varying along the axis of this member. So then we got it the total mass, at the same time elemental mass also we got it. Now we will use the theorem of varignon, so that we are going to be find out the centroid of these figures. What is the theorem of the varignon? That means the momentum of a force about an axis is equal to the sum of the moments of the components of that force is called the theorem of varignon. That's already we do have seen in the early video sessions. So in order to find out the centroid of this one, we need to applying the principle of moments. That's already we told, that is the theorem of the varignon. So in this case, what will happen? The body has its mass that is existed in terms of the elements. So that what I am going to be taking here, that's I am going to be taking del mi, right? So that's I am going to be taking, I is going to be here representing the 1, 2, 3, 4 up to the infinity number, and then the sigma I is equal to 1 to n numbers we are going to be taking. And the same I am going to be multiplying with the x distance, that I am going to be say the x bar. This is going to be the resultant momentum of this entire body, that is equal to the sum of the moments of the individual components. So that I am going to be taking the sigma del m1 x1 I am going to be saying. So from this axis already we have taken, so that this is going to be the O. So then this is the x1 distance is there from this reference axis. At the same time it is consist of del m1, right? That's what we have told. Each element has its own mass. So then that is what is the distance? That is the x1 distance we do have. And similarly, the second element we do have del. So in this case, del m2 x2 I'm going to be taking, plus del m3 x3, like that. The number of elements we have made it, that's the totally we have to consider here. So then how could you modify these equations in this way? So in this case what will happen, I'm going to be considering here that we know that the m is equal to rho into a into L we do have taken. So this is the total mass. But when you are considering the small elemental sheet, that's del m1 is equal to, I'm going to be taking rho a del L1 I have taken. That's already we have proved that part. So now I'm going to be substituting these two values in this equation. Then let me check it how we are going to be proceeding here. So in this case what will happen, I'm going to be taking here, that's going to be the sigma I is equal to 1, that's the end. Del mi I'm going to be writing rho a del Li I'm going to be taking, because rho and area is going to be the constant, that is the density as well as the area, and del Li we are going to be taking, that is into x bar I'm going to be considering, that is the with reference to y axis, that is the center is going to be located at a distance of x bar. So that is equal to this. How could you write it? That's going to be rho a del L1 x1 I'm going to be taking. This is the length of this part and x1 is the distance from this y axis. And similarly rho a del L2 x2, rho a del L3 x3, and so on. So like that, the number of elements what we have taken, that's we are going to be considering at this part. So now we are going to be simplifying this equation. In this case, can you see the rho a is going to be the constant terminologies. I'm going to be making the cancellation. So from this one, what I'm going to be getting, so that's going to be the sigma I is equal to 1 n del Li. That's going to be your x bar is equal to del L1 x1 plus del L2 x2 plus del L3 x3, and so on. So for this one I'm going to be simplifying, so that equations what I'm going to be taking. So for the simplification from the right side is going to be del L1, del L2, del L3 we do have. So then what is the simplification that I'm going to be taking? Sigma I21 n del Li then xi I'm going to be writing, because in this case 1 1 2 3, and that means each element we are coming in the sequence. So that's going to be del Li xi we have taken. From this side also we do have the same. So then what I'm going to do, I'm going to be taking this del Li, this is the elemental length is going to be, I'm going to be dividing there. So that is going to be x bar is equal to, what is the x bar here? That's going to be this, the sigma I equal to 1 n del Li xi divided by I is equal to 1 and that's going to be del Li. So this way we are going to be calculating the x bar. What is the x bar? That is going to be the centroid for this entire mass with respect to the y axis, right? So this, and similarly we can take it the y bar also. How could you write the y bar in terms of this one? Again we are going to be taking, this is the y bar, and wherever it is going to be have the x bar or x terminologies, we are introducing with the y terminologies. That suppose we are going to be taking, this is the y1 distance is there, y2, y3, y4 distance we do have. At the same time elemental length is equal to del 1, del L2, del L3 we do have. So then finally what will happen, we will get it that one. So we are going to be modifying this one, the y bar. This means the with reference to x axis, what is the centroid from the x axis? I am going to be say this part. That's going to be sigma I equal to 1 n del Li yi divided by, in this case sigma I is equal to 1 n del Li we are going to say. So this way we are going to be calculating the x bar as well as the y bar of this centroid that may be existed within this body or maybe outside the body also, where it is going to be, we are going to be calculating, or maybe existed here also, or maybe existed here. So that depends on the shape and the size of these objects. The centroid is going to be existed in the different locations. By using these equations we can calculate for the line segments.